I am Shubham Patel of SPT 19 and today my topic of discussion is Introduction to Sweetening in the Perspective of Refining. Let's see the processes involved in refining. First process is oil and condensate removal, second water removal, third separation of natural gas liquids, and the fourth is sulfur and carbon dioxide removal. So what is SAR gas basically? Basically, SAR gas is a natural gas containing hydrogen sulfide levels greater than 5.7 mg or 4 ppm by volume under standard temperature and pressure conditions. The term acid gas is used for the gas which is a mixture of CO2 and H2S, which also has some trace amounts of nitrous oxide. So what is a sweet gas? Natural gas is called a sweet gas if it contains only trace quantities of H2S and CO2. Now what is gas sweetening? The process is used for removal of acid gas or SAR gas are referred to as SAR gas sweetening. So why do we need to remove H2S? The reason is it forms weak corrosive acid in presence of water, is very highly toxic. It almost instant death occurs for concentration more than 1000 ppmb. At higher concentration, it forms very bad smelling compounds such as carbon disulfide, mercaptans, sulfides, etc. And what is the need to remove CO2? It also forms weak corrosive acid in presence of water and it reduces heating value of gas. Let's see some techniques of gas sweetening. The first one is amine sweetening process, in which amine gas is used. Different types of amines can be used for this process. For example, MEA, that is monoethanol amine, it is used in low pressure conditions. Other is methyl diethanol amine and it is used in medium to low pressure conditions. And the other one is diethanol amine, it is used in medium to high pressure conditions. It does not require reclaiming as required by MEA and DGA systems. The other is special solvents which are produced for special purposes. Overview of a natural gas sweetening plant. SAR gas is pumped up from the reservoir into the sweetening plant. Heavier components are removed and SAR gas is sent to the contactor tower for amine sweetening. SAR gas contacts the amine and carbon dioxide and hydrogen sulfide are removed. The flash tank condenses heavier hydrocarbons from the rich amine. Rich amine is filtered to be sent back to the stripper tower where H2S and CO2 are mostly removed. Amine is filtered and cooled to remove acid gases and other contaminants. After regeneration, lean amine can be sent back to the contact tower to be used again on the sweetening process. Now the second one is membrane separation. Membrane separation is technology which selectively separates material via pores or minute caps. For CO2 removal, we use glassy membranes made up of cellulose acetate, and for H2S removal, we used rubbery membranes made up of amide block copolymers. Now a video depicting membrane separation. So here we have membranes. Now gas will pass through it and all the contaminants will be separated out and we will obtain our natural gas which is free from all the acidic contents. Another method which we can use is by using an iron sponge. The process entails passing SAR gas across a bed of hydrated iron oxide. The subsequent reaction with hydrogen sulfide produces iron sulfides and a small amount of byproduct water. Iron sponge consists of wood chips covered with iron oxide. The material is placed in a vessel through which SAR gas is flowed. The H2S reacts with iron oxide to form iron sulfide. The spent iron sponge is remoistured with help of water. Iron sulfide is then released into atmosphere. Criteria to choose acid gas removal methods. First, type and concentration of impurities. Second, temperature and pressure of SAR gas. Third, volume of gas to be processed. Fourth, cost of the process. Fifth, environmental constraints. Sixth, size and weight of operating unit for offshore application. CO2 separation is done offshore, but H2S is not removed so as to reduce the problem of handling elemental sulfur. Thank you. I hope you enjoyed my presentation.